Hello, my name is Kevin Waman. I am the CEO of Twintivo. At Twintivo, we have built the world's first AI manufacturing system. And today I want to do a quick crash course of AI in manufacturing. After the last 2 years of explosive growth of AI, the thing that keeps hitting me is that I feel like manufacturing is being left behind in the AI world. There seems to be momentum behind manufacturing in the US. There's this massive push to reindustrialize, both by the government and from investors who are pouring capital into deep tech startups. Carta, which is the leading equity management platform for private companies, released a report in early January where it shows that in 2025, 36% of all funding into companies on the Carta's platform went into deep tech startups. So today I'm going to cover three things: the basics, the bottlenecks, and the actual use cases of AI in manufacturing. Well, let's start with the basics. I'll give you the conclusion up front. The current AI system does not work for manufacturing in its current state. Modern AI typically refers to large language models or LLMs, and those models were built on a simple magic trick, which is predicting the next word. To be technically correct, it's predicting the next token, but we're going to simplify it and we're just going to say that it's predicting the next word. These models were trained by scraping the public internet. That means billions of websites, books, and articles. It was approximately 40 terabytes of data for models that were considered smart in 2025, like ChatGPT 4.0. And that is exactly the problem. These LLMs know how to write Python and poetry because that information exists on the internet, but they were not trained on standard operating procedures, specific equipment configurations, or maintenance logs, because that data lives inside manufacturing facilities behind firewalls. It was never on the public internet and it will never be. So we have a massive gap. On one hand, we have this magical tool that can pass the bar exam, and on the other hand, it's completely disconnected from useful manufacturing data. And here's the thing: most manufacturers don't really care about concepts like fine-tuning an AI model, or how many billion parameters a model has, or what's the token per second input and output, right? What manufacturers will always care about is what's their OEE, what's their overall equipment effectiveness, what's their yield, how are they dealing with labor shortages, which is impacting all manufacturers across the United States. So that brings me to the second section of this crash course, which is the bottlenecks. What is keeping AI outside of manufacturing facilities right now so that it can actually be useful? It is two things. It is context and it is privacy. Let's start with context. So for AI to actually be useful inside a manufacturing facility, it needs access to the boring stuff. That means the historian database, the manufacturing execution system, and the tribal knowledge that's probably locked inside the head of a senior operator. But why is this important? It's important because when manufacturers feel comfortable to provide that context, they're able to get answers in seconds, not hours and not days. They're able to catch quality issues during production as it's happening and not at final inspection. And yes, this is where a lot of legacy providers and startups are working really hard to provide this superpower for manufacturers, which is good. But why is this not happening? To me, it sounds like a no-brainer. Well, the main reason is privacy. It's 2026, it's been more than 2 years since the big launch of ChatGPT, and if you ask the question, do you think that most manufacturers are sharing their data or internal context with AI models? Well, the answer is both yes and no. On the yes side, we have a tiny elite, maybe 1% of the US market, companies like Mercedes-Benz, that are already using AI simulations to retool their assembly lines twice as fast. It makes sense for them because these companies have the dedicated teams, they have massive budgets, and the talent to execute these ambitious plans. And they are the ones that are writing million-dollar checks for enterprise AI, and that's exactly why those big labs are giving all the attention to these companies. By the way, with those million-dollar enterprise deals, that means that they can actually negotiate on data privacy. But that's not going to be the case for the remaining 98 or 99% of what's considered to be medium and small manufacturers in the US. And that's where we have the no camp. Typically, shops or manufacturing facilities with under 500 employees. These type of manufacturers are stuck in a tough dilemma. They have to choose between using tools like ChatGPT or Gemini and hoping their trade secrets, intellectual property does not leak, or they just ignore AI entirely and they fall behind. And honestly, that fear is valid, and that's what I keep hearing from the interviews that I'm doing with manufacturers. I'm not sure if you're familiar, but there's a somewhat famous lawsuit between OpenAI and the New York Times. To keep that story pretty short, it started back in 2023, and even now in 2026, it's still working its way through the courts. Here's the detail that actually matters for manufacturers and concerns about their intellectual property. As part of the case, a federal court ordered OpenAI to hand over 20 million user chat logs, including conversations that users thought were actually deleted. Now, this is just one lawsuit, and we're going to have to see how it plays out, but it illustrates a bigger danger for manufacturers, which is once data leaves a manufacturing facility and it lives on someone else's server, then the manufacturer loses control of its data. But in 2026, here's a solution that I am particularly very excited about, and that is locally hosted open weight models living inside of manufacturing facilities. Now, let me explain what that actually means, because the terminology can get somewhat confusing. When companies like OpenAI or Google build these massive AI brains, they spend billions of dollars teaching them. The result of all that training is a file, which can be thought of as the model's memory or intelligence. And in the AI world, that file is called the weights. And of course, usually big tech companies will keep those weights locked up in the cloud. And when we want to access that intelligence, then they rent it out to us. So we pay monthly subscriptions or sometimes API keys so that we can access that on demand. But we're never able to touch that file itself because that's their secret sauce. And that makes sense. When I refer to the term open weight, that means that an AI lab, for example, Meta here in the US, they have decided to publish that file for free. So they took that secret sauce, they posted it online, and now anyone can download it. And 2026 is being a crazy year for this. On the last week of January 2026, there was a model called Kimi K2.5 that was released. And on several benchmarks, which is the way that AI models are ranked to see how smart they are, the Kimi model, including expert level reasoning, tests, and design, it ranked so high that it was beating or actually matching the top proprietary models from companies like OpenAI, Anthropic, and Google, which are the big three labs. As I am recording this video, there are actually two more open weight models that were released. The first one on February 11, 2026. It's called GLM-5, which once again, it's very, very close on different benchmarks to Anthropic's models, Google's models, and OpenAI models, which is insane. And then, as if that was not enough, on February 12th, there's a new model called Minimax M2.5, which is right now the open source frontier model designed for real world productivity. This model is quite crazy to me because at the moment, with early benchmarks, it's only 1 day old as I am recording this video. It's pretty much almost at the same level on SWE Bench, which is a benchmark for software engineering tasks, as Opus 4.5, which is the top model from Anthropic and considered right now to be the either first or second best model in the world. The slope is absolutely insane, and once again, we still have 10 more months in 2026. This is a real race right now in AI, and honestly, this is a big problem for the big AI labs, but for manufacturers, it's actually fantastic news. This approach that I'm talking about, the open weight, locally hosted models, also solves a big problem, which is the cost problem. Typically, when companies or consumers use cloud AI, in this case, a ChatGPT, let's focus on them, we pay per API call. So, an API is just how software systems talk to each other. It's not a new concept. So a request goes out. That means we ask something, what is the capital of Canada? And a response comes back. That's for a user. If a company wanted to use something like ChatGPT and use a lot more because they have more data volume, then they would get an API key, which is just a long string of characters that acts like a password to consume that intelligence directly from ChatGPT via the cloud. But with AI API calls, you are charged by the token. The token is a term that, quite frankly, I never fully understood the logic of it. But in AI world, a token is how words get broken into, specifically for large language models because they deal with words. In this example, you can see that technically I have a single word, hello world, it's put together, and then the tokens are two. In this case, I have a weird sentence that has numbers, that it has different symbols, and I counted personally, and it has approximately 50 either words or symbols or numbers, but then the token comes out to be 62. So doesn't make a lot of sense, but this is the way that companies charge you. How many tokens go in? So when you ask a question, how many tokens were generated for them to actually understand the question? And then the AI model through the cloud has to generate a response and give it back to you, and that also, because they created words to actually answer your question, that is tokens that they are creating to give back to you. So that's the output in tokens. But the beauty with local hosting is that manufacturers get fixed costs. It's not uncommon to hear enterprises, companies, startups paying anywhere between $20,000, $30,000, $40,000 per month on API calls to the big labs because, those models are really powerful, but they're also very expensive. And how do you control how much your internal team uses the tools, or how much your customers end up using the tools if you're providing a service based on top of the AI API calls? So what I'm trying to say is that typically you cannot predict exactly how much you're going to pay month by month, which is going to make it harder to come up with a budget for a year. But with this approach, manufacturers once again get fixed costs. It does not matter how much they use the AI, that bill for intelligence does not spike month to month. The other massive win with this approach is uptime. In a factory, if the internet goes out, which it can happen, then these type of systems can keep going because they do not depend on the internet. And that's reliability that operations managers or plant managers really, really demand. So I talked a lot about concepts and new solutions, but let me show you actually what's going in early 2026 as far as AI being practically used in manufacturing. So we're going to talk about the actual use cases. So the first case is manufacturing agents. Agents is a word or a concept that's somewhat common the last year, starting in 2025. The best way to think about agents is that they are computer-based, always on digital workers that can either work individually on a specific task, or they can have multiple digital workers that are doing jobs in parallel at the same time. There are legacy giants like Siemens, what we can see here on the screen, and Rockwell as well, among some of the big ones that are pushing agentic AI in manufacturing. Siemens has developed an industrial copilot that can deploy sub-agents. So that means you have a main agent, kind of like a boss. And then if I tell that boss, hey, you need to do 3 things, then that boss is going to be like, okay, I'm going to create 3 sub-agents under me that are going to go tackle those 3 things individually. One sub-agent for one thing, the other sub-agent for the second thing, and third sub-agent for the third thing. Come back to the big boss, the agent, and then get an answer. And they are using these sub-agents to troubleshoot issues inside of manufacturing facilities. Manufacturers have to be aware that, the catch with legacy providers of industrial solutions is that typically their AI innovations are going to come often locked to their hardware and tied to the cloud. So I personally believe that the future for manufacturers is actually vendor agnostic agents. The important concept in manufacturing is that you have different brands, you have different machines from different eras, from different ages, some more modern, some a little bit older. So it's important that the agents are able to be agnostic enough that they are flexible and they can work with different sources of data. That would push further the concept of interoperability, which is very big in manufacturing, especially in the world of Industry 4.0. And as we're transitioning to what people call Industry 5.0. Previously, we spent a bunch of time on context, but how do actually manufacturers connect AI to their messy and siloed data, especially if you're going to have an offline or locally hosted AI model? Well, the answer to that at the moment, it's called the Model Context Protocol, or MCP. MCP is the standard for interoperability and being able to give context to AI tools like large language models. This MCP standard was released by the big AI lab Anthropic in November of 2024. MCP can be thought of as a universal USB driver for AI. So to be more specific and more clear, for example, in January of 2026, Microsoft came out with a SharePoint and OneDrive MCP server reference. What that means is that the AI model, typically if you use ChatGPT right now, and if you wanted it to have access to context like a PDF, for example, or an Excel spreadsheet, you would have to manually upload those files to ChatGPT and then ask questions against those documents. And if you go into a new session, then you have to do that one more time, again and again and again. But now, as MCP has become the standard for all these interoperability and context for AI, you can see big players like Microsoft that now have exposed MCP servers so that an AI model can dynamically access the relevant context at all times from multiple sources, for example, inside of OneDrive or inside of SharePoint. Because data inside of manufacturing, once again, is messy and it gets updated every single day, if not every single hour. To be fair, MCP has both positive and negative reviews in the world of AI. Inside of the programming software world, it seems like some people don't really love MCP. I personally believe that in manufacturing, MCP can be very useful, but as things keep evolving in AI, which they do very fast, there might be a new standard that comes out in the future. For any engineer with some Python experience that hasn't tried MCP yet, I am showing this link to the official GitHub from Anthropic. So Model Context Protocol is the main repo, and then the Python SDK, the software development kit, can be used to maybe set it up. I could have referenced just a random generic YouTube video, but once again, because things get updated so fast, I think that it's best to get information from the actual source. A third use case that I think is really interesting and very useful for manufacturing are speech-to-speech interfaces. What I mean by that is that right now in AI, the state-of-the-art models as far as dealing with voice are not the ones that they get the voice, they transfer that voice to words, then that question, whatever was asked through the voice, would have to get answered in text, and then that text gets transformed once again to voice, and then the output comes out as voice. That's like a 4-step process. Right now, the best models in the world are directly speech, that's input, the understanding, and everything happens on speech, and then the output is speech to speech. No more 4-step process. So in early 2026, Caterpillar, the giant provider and maker of excavators, they came out with an AI personal assistant that's mounted inside of their excavators. So that means that operators can just talk to it. Potentially they can set like specific physical ceilings or limits for the arm of the excavator so it doesn't hit a power line, for example, without having to stop and type and get distracted. So it's really powerful. This concept can also be used inside of manufacturing facilities where you have an operator that's using a tablet or something similar, and if they're busy, if they have gloves, and if they have to log an issue, for example, they would have to take off the gloves, tap to 10 different screens, get to the place they need to like type something. In this case, they could potentially just talk to their app or their tablet and then log things immediately. So efficiency gains can be huge here with speech-to-speech models. For anyone that's curious about like potentially the most useful tools, January 15th of 2026, NVIDIA came out with a speech-to-speech model that's called PersonaPlex. Also open-weight, so someone with the required hardware can download it and actually run it. To be upfront with this model, you do need some NVIDIA hardware because the model is optimized for NVIDIA hardware. But this model is great for complex workflows. By the way, it's something that keeps blowing my mind. This model, the NVIDIA PersonaPlex, that was recently released in 2026, it's on par with OpenAI's leading real-time voice, which is called GPT Real-Time. And this GPT Real-Time, it's an incredible model. It feels very realistic. It feels human, but it's very expensive to run. Now with this local approach, if a manufacturer, once again, owns the hardware, the only ongoing cost that they would have is electricity. It would be negligible compared to the amount of money they would have had to pay for something like GPT Real-Time to run it all the time. So manufacturers can effectively take a potential recurring bill of thousands of dollars a year and just immediately slash it to 0. And for the last use case, and actually as a shameless plug, let me show you what we have built at Twintivo. At the beginning of the video, I mentioned that Twintivo is an AI manufacturing system. What does that mean? Well, our mission is to provide manufacturers with instant answers that are sourced. So that means that it's telling you exactly where it's coming from. After cross-referencing multiple data sources such as the maintenance log, the manufacturing execution system, the historian, live data that it could be coming on MQTT industrial protocol using AI manufacturing agents. How does that work? Well, let me show it to you. For a specific use case, let's focus on a step-by-step troubleshooting guide. So in this case, I'm going to show you what could be seen as an already documented step-by-step troubleshooting guide. In this case, focus on the G under heat 380. That's a specific guide. This gets triggered when the temperature drops below 380 degrees for more than 5 seconds. It applies to 3 different machines, IM1, IM2, IM3. We're going to focus on IM2. And then it should automatically give you 9 troubleshooting steps. So in this case, if machine 2, which is an injection molding machine number 2, has a fault or a failure, then Twintivo will flag it immediately. In this case, we can see that IM2 is having an issue. I get a notification, I get a visual alert, and then automatically the Twintivo AI agents are pulling troubleshooting steps, cross-referencing multiple data sources. As you can see here on the left, it created 9 troubleshooting steps that came from the document that it correctly grabbed the information from. As a source, you can see that it searched the troubleshooting guide, the PDF format. And once again, I mentioned initially to pay attention to the guide G under heat 380. It correctly identified the trigger, what machine it applied to, what was a correct guide. And now as an operator, if I have this, I can go through the individual steps, mark them as completed, and then send it to a manager for approval. If you're a process engineer, for example, you want to ask against live data, something that could take you 15 to 30 minutes, when the temperature to drop below 380 degrees. In this case, the data sample is for a month. So Twintivo will automatically look against that live data, and it will tell you the individual breaches as well as the total amount that temperature dropped under 380 degrees Fahrenheit. Once again, something that could take minutes, if not hours or days, can be solved in seconds. So look, I really get it. Manufacturing is hard. Hardware in general is expensive. People are hard to find and to keep inside manufacturing facilities. Culturally, manufacturing is not the most innovative industry typically. But as I mentioned in my intro, manufacturing is being left behind, and we cannot let that happen here in the United States. The next few years, if not months, should be filled with plant managers, process engineers, and operators who dominate this technology, who really learn how to use it, who are not intimidated by it. AI in manufacturing should not be used to take jobs away from people. It should be used to empower those people, make them stronger, more efficient, more capable. We have the tools. We have the solutions in 2026. Now we just have to move, and we have to move really fast. Thanks for listening to this crash course. If you have any questions, you can reach out to me, Kevin@twintivo.com. I'll see you in the next one.